Assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. I usually save this for the end, but if you've been enjoying the Dark Assassins podcast, I would ask that you would leave it a rating and review wherever you listen to it, and share with a friend or family member, and subscribe if you haven't already. I bet you didn't see that one coming, so I always got to keep you guys on your toes so you never know what's coming. Although what you do always know is coming is, of course, how we start every episode, which is the what nerdy stuff have I been up to this week? So, you know how last week I mentioned how I thought I fixed my router problem? Yeah, it broke again. It always happens to break whenever it does when I'm away from home and can't troubleshoot the issue. And the reason I figure out it's broken is because, I'll be out and about, and then I'll be like, I'm gonna go VPN to my home network real quick, and it doesn't connect. And I'm like, well, shoot. And then I go to my Linode server, SSH in, see that the IP address hasn't changed, and I'm like, well, this stinks. So, yeah, it broke again. I did check the logs, and for whatever reason, the PCIe network adapter that I've plugged in to give me extra Ethernet ports so I can actually have the router on the system, for whatever reason, that adapter, it says it got unplugged or disconnected, and then it caused a kernel panic and basically shut the VM down, and it was still active and it was still running, but obviously since its network was down because the network card was removed, it wasn't able to actually connect anything, and nothing was able to connect to it, and it was down, not having a good time. And I tried to do a rescan of the PCI devices to try to maybe get it back. That didn't work. So then I, just gave it the old reboot. And it came back online fine. And I'm honestly not sure what the issue here is. I am happy in the one sense that I figured out it was specifically the network card. Because before, I was wondering if maybe potentially it was a RAM issue, and the system ran out of RAM, and then that caused a crash. But that's not the issue. It was a network card issue, so I've at least narrowed the issue down. As far as why it's crashing, honestly, my best guess is so the card that I'm using, it's an old HP Enterprise card that was used in a server. And obviously, servers have really good airflow. If you've ever heard one, you'll know exactly what I'm talking about. They move a lot of air. So generally, cooling isn't that big of an issue in a server because there's going to be so much air moving through it that you don't necessarily need fans on things or beefy heat sinks on things. So this network card didn't have a heatsink at all. And obviously, since I just have it sitting in a old desktop, it obviously doesn't have as much airflow as it would if it was, in a server chassis. So my best guess is that because it's in a desktop case and it's really not getting any airflow, the best thing I can come up with is that the chipset on board to handle the networking is just overheating, and it's causing it to completely shut off, and basically essentially to save itself and not overheat and destroy itself and blow up. But so that's my best guess. And the reason why I'm kind of thinking this was because when it was running fine without issues, we were having cooler weather here, so my office, which is upstairs, wasn't blisteringly hot, but in the past couple days, we've been having warmer temperatures and the upstairs has been noticeably warmer, which also coincidentally coincided with when this card stopped working on me. So yeah, that's my best guess, is that it's overheating and shutting itself off. Thankfully, I did have a spare like thermal pad heatsink thing that I was using originally on a Raspberry Pi, and then I took it off and put something else on the Raspberry Pi. So I had this like little extra heatsink lying around. So I stuck that thing onto the chip of the network card. So I guess we'll see if that fixes the issue. I'm hoping it does, because that'll provide a better way for it to be able to dissipate more heat and hopefully keep it cooler. But, I thought I had it solved last week, and that obviously didn't work out. So I don't know. We'll see this week. Fingers crossed. It's just so annoying that it's fine when I'm at home and I don't really need to worry about it. And then when I leave to go, do my, my life and, go do things, go to work, whatever, that's when it's like, oh, he's gone. Now I can die. Like, no, man, come on. So hopefully we got it fixed. Oh, and I also mentioned last week that I had intermittent issues with it not booting if a display wasn't plugged in. Yeah, it won't boot if the display is not plugged in. I can reboot it without a display plugged in, and it'll work fine. But if I either had it powered off or, had it unplugged or whatever, and basically a cold boot, it doesn't boot unless there's a monitor plugged in. So it looks like I'm going to be buying one of those, another dummy connector to plug it in so it can actually boot in the case there's ever like a power outage or whatever. But yeah, so that's that saga. It still continues. And the other saga that still continues. So have any of you listening, have you ever played the game Whack-A-Mole? The one where like the mole pops up and you try to whack it, and then after you whack it, another one pops up and you whack it. Yeah, so I basically unintentionally of course, created my own Whack-A-Mole simulator. So if you remember the CPU benchmark API Python script thing that I wrote, yeah, it broke again also. For just the heck of it, I was like, you know what, I'm just going to update my spreadsheet that I have. So I ran the script and I was like, yeah, this looks good. Wait a second. Why does the overall score say NA? Well, time to fix it. So yeah, I had to patch that again. But like last week, as of the recording of this podcast, it is fixed. I guess we'll see how long this one lasts, but I'm hoping that I won't have to fix it for a while. That's my hope, but we'll see. So that was taking care of the stuff I broke. But before I get into the actual nerdy stuff I was doing that wasn't fixing stuff that I broke, I want to ask you guys something. And that question is, how well are you sleeping at night? Because thanks to today's episode, I'm kidding, we're not sponsored by anyone. I'm not going to make you guys sit through any kind of sponsorship like that, because I know personally I hate them, and whenever I hear them in a podcast, I always immediately pull up my phone and hit the skip 30-second button until it's over. So I feel like me doing that to you guys would be a little hypocritical. So yeah. Anyway, the reason I ask is because one thing that people claim that they lose sleep over is the fact that their passwords are pretty bad. And I recently set up a self-hosted Bitwarden instance to manage all of my passwords that way. So if you're unfamiliar, Bitwarden is a password manager. You can either use their cloud service and host your passwords on their servers, or you can self-host it like I'm doing, and your passwords are hosted on your own servers. And honestly, this has been working great. I configured all my machines and my phone to sync up to my Bitwarden server that I have running in my home lab, and it's been working phenomenally. And it was honestly, it was pretty darn easy to set up. Initially, all I had to do was spin up a few Docker containers, which they had like an entire walkthrough guide on their website, which, from what I recall, you basically just download a script, and then you run the said script, and then it pulls all the Docker containers you need, and asks you some questions as far as like setting up the environment yourself. Different things like what's your domain, and some other like configuration stuff. But the domain aspect is kind of where it starts getting challenging, because it's in a good way. It's a good thing and kind of annoying at the same time. So from a Bitwarden client, if you try to connect to your self-hosted Bitwarden server, and you don't have a valid certificate, it won't work. It'll just refuse to connect. So you have to make sure you have a valid certificate. And this can be kind of sort of a problem if you've never dealt with certificates before. So that's kind of another thing that I got deep into, which I'll get into the whole certificate thing in a little bit. But on the fact for the self-hosting Bitwarden myself, I don't have anything against Bitwarden, to be honest. I think from what I've heard about them, they're very well respected in the security community. They go through tons and tons of audits, and they're very transparent about their security practices, and all the source code for Bitwarden is open source, which is pretty awesome to see. But the main reason that I wanted to self-host it was mainly just because, I got the hardware to do it. You guys hear me talk about my home lab all the time. I got the hardware, I might as well put it to use, right? But the other thing too is it just adds an extra layer of security, knowing that my passwords aren't out in the cloud somewhere. They're secure on my server. I know exactly where they are, secured not only behind my LAN, but also segmented off even further on my own like internal server network, which just adds just an extra peace of mind, knowing that it's basically I'm not going to say it's impossible, but it's essentially a 0.0000001% chance or something like that someone's going to hack in and get my passwords and all that stuff. Now, I'm not saying that if you have your passwords in the cloud that they're, your passwords are going to get stolen and you're going to get hacked, because as long as your master password is a really solid password, with how much encryption these password managers do for your passwords in the cloud, no one's going to be able to get your passwords. So it's not, a bad thing to have them in the cloud. I just like that little extra layer of protection between my passwords and potential people trying to steal my passwords. So that's that. Now, as far as setting up the certificate goes, so for this, I use pfSense for my internal server network, and pfSense has so much capability in it that I'm probably barely even scratching the surface of. Actually, I know I'm barely just scratching the surface of things that it can do and what I'm actually using it for. But one of the things it can do is act as a certificate authority, so you can basically have your own internal certificates. Now, basically what I was able to do was set up a certificate authority with my pfSense box, create a root certificate, and then with that root certificate, I can go sign server certificates that I can go upload to my servers. Like, for example, I can upload it to my Bitwarden server, and then as long as that root certificate is installed on my devices, which I made sure it was, then I can seamlessly connect to the Bitwarden server, no problem, and any other server that I have running with a certificate signed by this root certificate. Now, I know that was kind of a lot, so if all of that went over your head, don't worry about it. You're probably asking how this works, and basically the short answer is a ton of math and a ton of cryptography. So the best way that I could come up with to kind of make an analogy for how these certificate authorities and root certificates and server certificates and all that works is, as much as I hate comparing it to school because I hate school, there's honestly it was a great analogy from what I could come up with. So here's the analogy. Basically, if you think of the server certificate like it's a diploma, and the certificate authority is the university, that's basically kind of the relationship in a way. Because when you think of, the reason why the certificate that originally came with the Bitwarden instance, it was a self-signed cert. And basically what that means is the server created its own certificate and with its own root authority and all that stuff. So the reason why that caused issues was my computer or phone or whatever reached out to that server, saw the certificate, and basically the computer was like, yeah, I am Bitwarden, and the reason I'm Bitwarden is because I say I'm Bitwarden. And my computer's like, that's a little sus, man. You're saying you're Bitwarden, but no one's vouching for you. The only person vouching for you is you. I don't know about this. So that's kind of why, because my computer didn't have the root certificate installed and it wasn't trusted, so it couldn't trust then the server certificate on the server. So let's bring this back to the diploma example, because I think that might clear some things up for people. So basically the reality of it is anyone can print a diploma and sign it themselves and claim they got a degree from some university, right? But if you print it yourself, it's basically worthless unless there's a university out there that is certifying and signing off and saying, yes, you actually did complete this degree and you earned this diploma. Now, the thing of it is you have the well-known universities that everyone knows, right? You got Harvard, Princeton, Yale, Florida, Texas, Penn State, Oklahoma, USC, all the big name schools that everyone knows. And if anyone sees that you got a degree from one of those schools, they're not going to question it. They're going to be like, yeah, that's legit. But if you got a school from the College of Podunk Nowhere, people might start scratching their heads and be like, is that a real school? So that's basically what's going on with your computer when it goes to a website and the certificate isn't trusted. Now there's the main certificate, there's a lot of root certificate authorities out there, like Cloudflare is one of the big ones. I believe VeriSign's another one. So basically, these big namers are your big name schools, right? Everyone knows them. So these certificates from these certificate authorities, their root certificates are installed on your machines by default. So your machines know if they see a certificate from a website from Cloudflare, they know it's legit. So the reason why it didn't work in my case was because the new certificate authority that I made wasn't installed on my machine by default, so I had to install it manually myself, basically telling my machine, if we go back to the diploma example, that, hey, this university that's going to be signing these certificates, it's actually a legit university, so you can trust them. And if we go back to this university example here, if you see that someone got a diploma from, the College of Podunk Nowhere, At first, you're probably going to scratch your head and be like, I don't think that's legit. But then you realize upon your research that the College of Podunk Nowhere is actually a legit school. Then any other time, and you know it's a legit school and you can trust it, and you know, you say you went through their website and you saw that they have a legit curriculum, and you know they're an actual real school and all this stuff. So then after that, you have essentially have their root certificate, you know they're real and you can trust it. So then any other time you see a certificate from a diploma from the College of Podunk Nowhere, you know that it's legit and you can just trust it. So going back to the certificate authority that I made, so basically I created the own certificate authority, gave all my machines the root certificate, and trusted it so they know if they ever see, you know, I guess a diploma or a certificate on a server signed by them, they know that it's valid and they can trust it. So basically the point of the root certificate from a certificate authority is basically to vouch for that website, to say, yes, this is a legit website. Which is why if you ever go to a website that isn't self-hosted by you and you get that like big scary warning message saying that like the certificate isn't valid, that's basically what's happening. There's really two reasons why it would be invalid. One is the certificate's expired, which can be kind of sort of common, although generally nowadays that's not as common with how much I know, like, if you use Let's Encrypt, for example, which is a free way to get a certificate for your website, that, like, they have, like, an auto-renewal thing set up for that. And I think a lot of certificates generally have some kind of auto-renewal set up, or if it's, like, a big-name company, they're going to be on that anyway. So generally, an expired certificate isn't as common, but the bigger one is a self-signed certificate, where the website creates its own certificate authority and then grants its own certificate itself. So that's like me saying, I got a degree from Dark Assassin's Podcast University. Like, that's obviously not legit, right? So now if I told all of my computers that Dark Assassin's Podcast University is a legit certificate authority and gave them, you know, my root certificate, then they would believe me. But obviously, you know that is not legit. So yeah, that's the biggest thing if you're going to self-host your own Bitwarden instance, to make sure that you are able to somehow set up your own certificate authority. Now, another thing you can do is there's a way that if you want to get really into the weeds, you can actually go through the process of like setting up the root certificate on the Bitwarden server, and then doing a bunch of command line stuff to generate a root certificate and then the server certificate, and then download the root certificate and install it yourself. You can do that if you want. That's what I originally did, but that was kind of a pain. And the nice thing is if you have an actual legit certificate authority, like through pfSense, for example, then you can just make as many server certificates as you want, and you don't have to manually install a bunch of different root certificates for every, you know, server certificate you're making. So since I have the root certificate from my pfSense box, now any time that I want to generate a new certificate, my devices will automatically trust it. So one of the other big ones that I did was I set up a certificate for my GitLab instance that I host for, you know, my own private Git repo. And before that, it had a self-signed cert, which I was able to kind of work around and bypass by every time I wanted to push something there. I basically had to make sure that my local git config file had SSL, or basically the certificate verification turned off, because if I didn't have that verification turned off, it would see that the certificate wasn't valid and be like, hey, this is kind of sketchy, don't want to push here, and it would abort every single time. But now that I actually have a legit certificate on there, that's not an issue anymore. So that's cool. So yeah, it's honestly a cool project. And I've honestly kind of become numb to the that, warning message of, this site could be dangerous because it's using a self-signed certificate or whatever, because all the websites that I access in my home lab that use self-signed certs. But I think eventually I'll probably slowly get around to the point of actually installing legit certificates from my certificate authority on all these devices and servers, and get that all working so I never have to see those anymore. Because I will say it is kind of nice going to certain services in my home lab that I actually have it configured on now, and never actually having to see that pop-up message. So that is pretty nice. So now getting on to the main topic that I actually wanted to talk about in today's episode, and that is the concept of serverless. So if you've been kind of in or hearing about or looking into the cloud computing sphere at all, you might have heard of serverless before. Now, up front, serverless is essentially a big lie, because serverless is not actually without servers. There are servers behind the scenes, which I'm not going to lie to you, when I first heard the concept of serverless like a few years ago, it completely boggled my mind, because I was like, wait a second, how the heck can you run stuff in the cloud and stuff if there's no server? Like, what? Like, I got so confused by it initially that I kind of don't want to admit it, but it's true. So if you're out there and you thought serverless meant there were no servers involved, I was right there with you. But basically what serverless is, it's like a subsect of a subsect of cloud computing. So in cloud computing, there's a subsect called utility computing, and then a subsect of utility computing is serverless. So basically what serverless is, it's a function as a service thing. So I know nowadays the hip thing is to have something as a service. So you have software as a service, infrastructure as a service, platform as a service, functions as a service, so many things as a service. I guess that's the hip thing that everyone's doing nowadays. But anyway, basically what this allows you to do is it allows you to seamlessly scale your application based on the needs that you have. So instead of you spinning up a virtual machine with, say, 10 cores and 32 gigs of RAM and a terabyte of storage, sitting there doing nothing for 90% of the time and then being maxed out for 5% of the time, and then causing a bunch of lag and slowdowns, and then kind of, being able to handle everything that it's coming through the other 5% of the time. What serverless would allow you to do is, during those downtimes when you're not getting any traffic, you don't have to do anything. And then once you get absolutely slammed, your application will dynamically scale to accommodate for that ginormous load, before then kind of tailing back off as the load decreases. So the reason why this is really nice is, from a price perspective, you're only paying for what you're actually using. So that 90% of the time where you're not getting any traffic, that's 90% of the time that you now no longer have to pay for. Whereas if you had a virtual machine, you would have to pay for that 90% of the time, assuming it was up and running. So, and then the other benefit of it too is, because it can dynamically scale, you're not running into that issue where your system's pegged against the wall because it's being, absolutely hammered with traffic and it can't keep up because, the VM you made wasn't beefy enough. So that kind of takes that out. So that's kind of like an overview of how it works. So now how it actually works, how you implement it. First, what you do is you write functions, and then they can serve either one or more purposes. for a given application, and then you write additional functions that are basically act as event triggers. So these can be anything from like, when I receive an HTTP request, run this function, or if I receive an SQL request, run this other function, or whatever the case may be. You can set up event triggers to run your functions, and then once one of those event triggers occurs, then the provider of your serverless infrastructure will then go and run the requisite function. And then if you have like a front end website, then whatever that action was will be displayed to the website. But this works actually really well with another kind of utility computing thing, which is a service-oriented architecture, basically called microservices. Now, what microservices allows you to do is, rather than making like one gigantic monolithic application, you basically divide it up into smaller applications, which are services, like, the individual services of it, or individual functions. And I think one of the best examples for this kind of architecture is if you think of like a Docker or like a Kubernetes type thing, where you have a bunch of like smaller containers that you can kind of like pull together to form like an overall application. Like, for example, Bitwarden that I have installed is a great example of this. It has a bunch of different Docker containers that it all uses together to form one application, which is Bitwarden. So what this allows you to do is, if you ever need to push updates to something, like say your backend or the front end website or the database, you can just make those changes to that specific thing and push that without having to change anything else of the application. You don't need to recompile it. You don't need to do any of that. So that is one really nice thing about it. And the other nice thing with this whole serverless thing is, because everything automatically, dynamically scales for you, you essentially just push your changes to this one place where whether that's AWS or Microsoft Azure or wherever you're hosting your serverless infrastructure, you essentially just push that code there, and then it's automatically deployed and can automatically scale up and down as you need it. Whereas in a traditional cloud computing setting, you would have multiple virtual machines most likely scattered across the globe. And the reason you would do that is for essentially load balancing for one, and also for latency too. Because if you have all your servers, say, hosted in Dallas, Texas, and you have people from, China or India or, Europe or Germany or, wherever on the other side of the world, there's going to be a lot more latency for them to get to your website than it would be from someone in Austin, Texas, for example. So the reason in traditional senses for cloud computing, you'd have basically machines deployed across data centers all over the world. So when someone would try to access your website, they would go to whichever server is closest to them to get the best, reduce the amount of latency involved. Now, if you had a bunch of different servers deployed across the globe like this, in the traditional sense, if you just had one monolithic application, you'd have to push that application to each one of the servers. Now, there's a lot of ways you could automate this. Ansible's one of them, to basically auto-push your code to everything. But regardless, you would have to stop the application, most likely, and then in order for you to push your code and then restart the application, which could potentially cause downtime, and it could also potentially cause latency if, say, the person in Singapore trying to access the server closest to them goes down because you're pushing the new changes. So instead they have to route all the way to your Dallas, Texas office, right? That's going to be a lot longer for them to travel, so there's going to be more latency. So that's another thing. Now, so this was basically what makes it, really, really, desirable and really a good development practice, because what this also allows you to do is, because you don't have to worry about all this infrastructure stuff, you can focus strictly on just developing. You can focus strictly on the code and making the best application possible. And then, so you have that benefit. And then there's also the benefit that because you don't have to worry about all the infrastructure stuff, you could potentially reduce your staff by not having to staff people to deal with the infrastructure. You can just have developers. And then, as I mentioned, another benefit to this is you're only paying for the time that your functions are running. So rather than a typical cloud computing sense where you're paying for the uptime of your VMs, sometimes just strictly if the VM's up, and then some providers will charge you based on how much usage they'll charge you a flat rate for having the VM on, and then they'll charge like additional fees for like how much usage it's getting. But the thing with serverless is you only pay for the time your code's running. So for example, if we have that 90% time no one's accessing your application, that's 90% that you no longer have to pay for. Whereas if you had a VM on the whole time, you'd be paying money for all that time. So that's another benefit. You could potentially see lower costs because your code's only running. You're only getting billed for when your code's running, so that could also potentially reduce costs. So that's from the consumer side. Now, on the cloud provider side, they have the added benefit of if everyone switches over to serverless, they don't have to worry about loaning out resources to virtual machines to people that are basically going unused. Because I know from personal experience, my Linode server is basically doing nothing. I would say probably 99% of the time. Now, granted, that's using, I think, a shared CPU core, and I think it has like a gig of RAM and like 25 gigs of storage or something. It's the base tier. It's like because I'm cheap like that. But if you think like a bigger business that might not be getting like a ton of traffic, but they want to make sure that their infrastructure is big enough to handle more traffic, they could potentially be having VMs just sitting there unused that the cloud provider obviously has to provide for them, but that's resources that they could essentially be better used elsewhere. Like, for example, in the serverless environment, they could, rather than having those 10 cores sitting idly doing nothing, they could instead have put those 10 cores over to this other serverless application that's currently getting hammered by traffic and it needs to scale more, provide more resources to them. So by having a serverless infrastructure here, if they could devote more resources to that, rather than, VMs just sitting idly doing nothing, that could potentially give them more revenue in the sense that they could provide more serverless applications and, be able to expand and better handle, big spikes and everything. So that's a lot of benefits to serverless, but like anything in the technology sphere, it's not all sunshines and rainbows. So some potential reasons why you might not want to use it. One of the biggest ones, I guess there's two really big ones. And one of them is that trying to debug these things can be a real pain in the butt. Because if you think about it, you're essentially pushing this code to a cloud service provider. And what happens is every time your code gets hit with a request, it creates a new instance of it to run your code, and then it kills it. Which is good in the sense that it cuts down on, your compute time, and it can potentially make your build cheaper. But if you're trying to debug an issue, it can be hard because if you try to write a log file and log any errors that might occur, if the instance just dies after it's done running, well, that log file is not going to do you anything, right? So it makes it you can't just simply throw the program into your debugger and figure out what's causing the problem. And if you're like a baller and you use a print statement rather than a debugger. Like I mentioned last week, me using a print statement rather than an actual debugger, which don't do, by the way, use an actual debugger. But even if you were using a print statement, you wouldn't be able to do anything because, it would print out your debug statement and then it would kill. It would just die because, it's done running its code. It can be done now. So trying to actually debug these things can be a real pain. So I think there are some like third-party tools that like for example, in AWS, I believe they provide a third-party tool, but I mean, it's still not easy, which I guess on the one hand, if you don't have to staff infrastructure people to manage all your server infrastructure, you could afford to pay your developers more that are actually good at figuring this stuff out, maybe. I don't know. And then another kind of problem with serverless is you're essentially locked in to whichever cloud provider you go with. So example, if you go serverless with AWS, trying to migrate that to another provider can be kind of a pain also. Because unlike a virtual machine, you can't just package it up and migrate it easy, no problem. This is not how this stuff works. And then kind of piggybacking on it not being a virtual machine, because it's running in its own environment, you don't have control over that environment. So there could be security issues with that. So sometimes it is better to have your code running in your own environment because you can better control the security around the code rather than it just arbitrarily running in some environment. So that might be another reason why you'd want to avoid it, is you want to make sure you have full control over the environment that it's being utilized against. So those are kind of some of I would say, the big issues of why you might potentially want to avoid serverless. But also then again, I mean, this is coming from me, spinning up VMs is fun, right? Like, I mean, I enjoy playing with virtual machines. I personally haven't really like done any of this serverless stuff. Like I haven't, deployed any serverless, I guess, real serverless applications in the cloud. I guess technically that Bitwarden instance I installed I guess you could kind of maybe see that as a serverless application, but it's more, I guess, microservices rather than serverless because it can only scale as much as the resources that it can take up in the VM it's running in. So it can't take over every single core that's on my server, my overall server. It can't do that. But I guess it is what it is. But yeah, serverless it's definitely a cool technology. I think kind of I don't know if I necessarily do I see. I guess another question is, do I see it being the future, like for cloud computing? I mean, I think the premise of having that on-demand, auto-scaling everything is super slick and super nice. So I think it'll definitely, I mean, it's already taking a chunk out of the market and it's becoming popular. But I kind of have a hard time seeing virtual machines completely going away. But I definitely think that, as people kind of figure out how to develop for this better, especially if they can actually figure out debugging tools for it, that'll make it a lot easier to develop for. I think that would be nice because especially, if you think back to someone wanting to host stuff in the cloud, if you don't have a lot of money, this could be a great, experiment to play around with, because if you pretty much know that you're going to be the only one accessing your application that's hosted in serverless, the nice thing about this is you could essentially pay zero for it, like in a given month if you don't access it. Whereas if you had it running in a VM in the cloud, then you'd be paying whatever the rate is for the virtual machine. So there are definitely some potential benefits there, for sure. So I don't really have a good way to wrap this episode up. I didn't really think of a good one. But I already mentioned in the beginning of the episode, but I'm going to also mention it again here at the end, that if you enjoyed this episode, that I'd ask you to leave a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. Also, be sure to share with a friend or family member that would maybe want to hear about certificates for servers or want to learn more about serverless. And yeah, so if you have any questions about this episode or have any topic ideas you want me to cover in future episodes, you can shoot me an email at contact@darkassassinsinc.com. There is a link down in the show notes below that you can click on for that. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.